very interesting topic. The first one is, of course, the EOR using the microbes. Second one on the subsea pipeline. And third one is, of course, the seismic. So it's a different type of topics altogether, but all are very relevant for the oil and gas sector upstream. So without taking much time, I hand over to Professor Roy to take the stage.
Good afternoon. Thank you, Mr. Sinha, and welcome to everybody for this last session before lunch. Like Mr. Sinha said, it promises to be a very interesting session with three very interesting talks. So I'm honored to welcome the first speaker, Dr. Kamalakshi Devi. Dr. Devi serves as the Deputy Chief Biotechnologist in Oil India Limited, and her current research portfolio is centered around petroleum biotechnology. And she has made some very seminal contributions in the area of microbial enhanced oil recovery, microbial gen prospecting for oil and gas, bihydrogen producing bacteria, and biosimulation methanogens, amongst others. So, Dr. Kamalakshi Devi.
Thank you for the generous introduction, sir. Respected speaker of the session, my co-speakers, respected delegates, my seniors, colleagues and friends, a warm good morning to one and all present here. So, microbial enhanced oil prospecting, and I am here to tell you about harnessing the power of microbes, implementation of a sustainable green MEUR technology. So moving forward, microbially enhanced oil recovery is one of the most cost-effective and environment-friendly technology present in current scenario of EOR. So, as you can understand that microbes has infinite untapped potentiality, and we want to leverage this potential of microbes, of specifically our native microbes, our benefit. So we try to identify few microbes which are able to help us in oil recovery. These microbes basically has the ability to produce biosurfactant, organic acid, along with many other organic metabolites that are functional and useful for enhanced oil recovery. And let me tell you one thing. Oil India, being the pioneer E&P company in India as well as in Asia, I would like to tell you something that, believe me when I tell you, this company has fields which are century old. So now you can imagine the challenges our production group is facing every day with depleting reservoir, with high water cuts, and to keep up with this production rate with this challenging environment. So with these things in our mind, our R&D have taken up this project to tailor a MEUR technology which is our own, which is in-house, and which is specifically tailored for mature reservoir, all kind of mature reservoir. So moving forward, I would like to go to the methodology, how we actually go forward. Initially, we isolated bacteria from our oil's operational area. Then we try to find out those bacteria which are actually useful for MEUR. And once we are successful in this method, we could zone down to this useful, efficient bacteria to produce one consortia. Then the second challenge comes, that is, we have to have one nutrient which is cost effective, easily available, and implementation is possible in our fields. And finally, when both these challenges are met, we selected the wells in our operational areas and executed this technology in our fields. So let me break down this methodology a bit. So initially, we have collected the wellhead samples from different wells of oil operational area, and from these wellhead sample, we have isolated a plethora of microbial isolates. Now the Herculean task was how to zone down those efficient microbes which can actually help us to do our main target, that is enhance our oil recovery, because we need some microbes which has the potentiality to produce and excrete biosurfactant, and as a result which will reduce the IFT inside the reservoir and increase the flow of oil and enhance our oil recovery. So with a very complex screening process, we could zone down to few microbes, few efficient one, and we could achieve this consortia, which is our very own in-house MEUR consortia. Once this challenge is achieved, second point came where we need a field implementable nutrient recipe. Here, we are very lucky enough. In Assam, we have lots of fields, and from field we could extract a plant-based nutrient recipe, which is organic, which is rich in nutrient, and those microbes can thrive pretty well in this recipe. So both these challenges are met pretty nicely. Then the third thing comes, that is the to select the wells. So for selection of wells, there are a lot of criteria, but the basic criteria that we have found the best for our technology, where the bottom hole temperature should be in the range of 70 to 95 degrees centigrade, and the water cut should be between 30% to 90%. But it is not practically always possible to get this kind of wells. So our production group, we have given us 9 such wells, which is more or less coming within the criteria. So the actual wells that we got to work with were from bottom hole temperature, we're having bottom hole temperature of 77 degrees centigrade to 128 degrees centigrade, and the water cut was from 61% to 98.4%. So you can imagine our challenge. But anyhow, we taken up these wells, and we implement our technology through single well intervention process. We prepare our consortia with the field implementable nutrient resources in the field itself. Then we deliver this consortia directly in the mid perforation range of the well through coil tubing unit, and then we keep this well shut in minimum for 7 days. Once 7 days is over, then we bring back this wells to production, and then finally we go for the evaluation of the technology. So for evaluation, we go for pre-job and post-job performance of the well. So as you can see here directly, although we are not very much we are very much in production rate, high in production rate, but in few wells we got very good result. And the best thing is, in all the wells, we got increased oil production. You can see the increase was found to be 8% to 59%. And if you see the graphical presentation, upper 2 bars are for oil production, where top one is post-job, bottom one is pre-job. And the below two bars with blue colors are for water cut, post-job and pre-job. And from here it is pretty clear, in all the wells there is increase in oil production. But in case of water cut, except in well number 6, in all other wells water cut has reduced. But in well number 6, both oil and water increase. So finally we got increased oil production. Now you can ask me one question: why in well number 1 we are getting such a beautiful result? If you see the figures towards my left, the production of oil has increased mere 19 barrels of oil per day to 223 barrels of oil per day, which is a huge quantum gain of 204 barrels of oil per day. So this is because this is the only well which ticked all the criteria we have set for the selection. So if we could get this kind of well, so we can assure that we can give really, really good result with this technology. But anyhow, in other wells also, you cannot say we are failed because we have increase in oil production. So finally, I would like to say the key observation of our experiment. So in all the wells, we find an increase in 8 to 59% oil production, and in case of directly in barrels, if you see the figures, it is increased from 2.5 barrel to 204 barrels of oil per day. And the best thing is this increased production has sustained for several months. So this way we can say this technology is working in our depleting reservoirs. Second point, this technology worked really well in high water cut wells, and even this is working in very deep wells also, like wells with more than 4-kilometer depth. So, and finally, it reduced the downtime as compared with the other technologies. So we can finally say this is a highly adaptable technology in diverse condition. So with this, I would like to conclude that this indigenous green MEOR technology is proven to be effective in the reservoir conditions, in various reservoir conditions. It is eco-friendly, it is scalable, and it is cost-effective. And finally, I would like to conclude with the statement that this technology gives sustainable incremental oil recovery with minimal surface and environmental footprint. So with this, I come to the end of my presentation, but I would love to extend my heartfelt thanks to the India Energy Week team for giving us this beautiful opportunity to present our work in such a huge platform. I would love to thank our oil management and all the departments of Oil India Limited which have helpful and instrumental in making this technology successful. And finally, I would like to thank our HOD Madam Eva Kolita, who have been a very supportive guide throughout this process. And at the end, I would like to introduce my co-author, Dr. Deepak Jyoti Kolita, who is present here. And another author is also here with us, Dr. Ranjan Bhagwati, but he is in Hydrogen Pavilion presenting another innovation of Oil India Limited. So with this, I would like to conclude and thank you all for your kind listening and patience. Thank you.
Thank you for that very insightful talk. I think our next speaker is Dr. Suhas Gadgoli from Dravin Engineering. The title of his talk is Delivering Subsea Flowline Infrastructure, Global Expertise, Local Advantage. To introduce the speaker a little bit, Dr. Suhas is an engineering and business leader. He has been in the business for more than 25 years with global experience across oil and gas, offshore, automotive, and aerospace sectors. He has worked in many international organizations and collaborated with teams and clients across the United States, United Kingdom, France, Spain, Brazil, and India. Suhas, thank you.
Good afternoon, Honorable Chair, Mr. Sinha, Professor Shantanu, my co-speakers, my industry colleagues. Thanks for attending the session. Hope you're all enjoying Goa and the event here. Let me start by introducing ourselves. I'm working in Dravin Engineering. It's part of a Deep Sea Technologies group. It's a global company in oil and gas, specializing in surface and subsea. Yeah. So my introduction is already given, so let me move over to the next slide. Yeah. So as I was explaining, we have a global presence in oil and gas. Geographically, our major presence is in the United States, offshore Brazil, UK, and we have other companies located in India and UAE as well. So we specialize in engineered equipment supplied to independent energy companies as well as Tier 1 contractors. So this pretty much covers our capabilities across subsea and surface. So we can say that except for Xmas trees or the Christmas trees, flow lines and umbilicals, we have a capability to engineer and supply all of the equipment, whatever you can see here. So some of the main equipment I can show are the subsea manifolds, then plates, plems, then bend stiffener connectors for the load transfer on the surface. Then we have umbilical termination assemblies, subsea flying leads, then topside termination units. Then we have the umbilical installation reels. Then we have reel deployment systems for SFLs and umbilicals. Then we have a capability of MPD systems and AWOC systems, to name a few. We also have a portfolio of our product line. The major ones being flow line connectors with vertical and horizontal connectors. Then we have our own stab plates, which are called as MQC, or multi-quick connects. So let me show you some of the glimpse of our global presence, our divisions across the countries. That's our Houston facility. This is WW Industries, one of our group companies specializing in fabrication of process and structural equipment. This is our UK facility. So we are present in Liverpool and Aberdeen. These are our facilities in Brazil. So we are present in Serra and a portside facility there. This is our Indian facility in Hyderabad. This is our sister concern, Shawad Industries, providing manufacturing support, specializing in machining. This is Dravin Engineering, where we provide full-scale engineering support for all the equipment which are used in subsea and surface. So let me show you some of the pictures of the equipment. This is integrated MPD system, some of the flexible flow line support equipment. These are bend stiffener connectors for load transfer for the umbilicals and flexible flow lines. So we do a lot of subsea distribution systems, including SUTAs, HDUs, SFLs, including EDUs. This is one of the UTAs. So we do have a capability of working with super duplex tubing. All the equipment with the super duplex tubing, we can make them in-house. So let's move to one of our case studies, which we executed recently. This was for a subsea field development. Basically, it's a greenfield development for offshore Brazil. So this involved subsea production system equipment, except for the flow lines, umbilicals, and trees. So we supplied pretty much everything to the customer. The water depth here, you can see it's 1 to 1.5 kilometers, which is quite high. And that is one of the challenging parameters in design of the equipment. So there you see all the equipment shown in yellow, they're all supplied by us. I'll share with you the methodology developed going forward. How did we execute the project? So I hope most of you know the functionality of the equipment. Just for the benefit of audience who are not well versed with the equipment here. So at the center, you can see the Christmas trees. This pointer may not, it's not working. At the center, you have a Christmas trees wherein the fluid is produced and transferred to the manifold through jumpers. And from manifolds, you have plates. Those are pipeline and terminations. From there, the hydrocarbons are passed through the ILS, flow lines, ILSs, a number of ILSs basically, which act as injection points. Then finally reaching to the plate towards the surface where the fluid is transferred to the manifold and then gotten into the surface FPSO. Then on the orange color lines, what you see, those are the umbilicals, and at the end structures, those are subsea UTAs to terminate the hydraulic fluid, which are used to control subsea equipment valves. Then in addition to that, we have electrical and optical controls terminated on the UTAs, which are again passed on to the trees or manifolds to control some of the functions. So these are some of the equipment which will give you an idea of the sheer size of the equipment. The first one on the left, top left, is a PLET, pipeline and termination. So we did a couple of them there for this project. On the next slide, I'll cover exact number of the equipment, what we supplied. On the right is a cluster manifold. Two of them we designed, manufactured, and supplied. So on the left side, we have the SFLs, or subsea flying leads. These are basically steel tube flying leads made of super duplex tubing. Then the stap plates, what you see on the ends here, they are our own products. Basically, we have, as I said earlier, we have our own product lines. On the right, you see the subsea UTAs with HDM and EDUs. These are on our yard. And on the right bottom, you have the UTA jumpers, which are connected between SDUs and UTAs to transfer the fluid. So this gives a screenshot of what scope we executed for this project. It's a fairly large project. On the top, you see manifolds. That's 9-inch dual header and 6-inch 4-slot, which is already delivered, one of them. Second one is being built. Then we have PLEMs and PLETs. PLEMs are in progress. The PLETs, 2 of them have already been delivered and installed. Then ILSs, which are for 9-inch line, 3 of them are already delivered. Then SUTAs, 17 of them were manufactured, tested, and delivered. They are being installed as we are speaking here. Then we have UTA jumpers, 15 of them. Then HDUs, hydraulic distribution units, which are mounted on the same mud mat as the UTAs to transfer the fluids. Then we have STFLs. We supplied 35 of them. Then subsea stap plates. So one of our product lines, we supplied 215 in a record time. Then the last one being rigid jumpers. So these are the M-shaped rigid jumpers, which are used to transfer the fluid from one subsea structure to other, mainly the subsea trees to the manifold or trees to the plex, based on the configuration. So since this was a complex and large project, so we had to have a definite plan of execution, because the customer had given us a really strict deadline. One of the first thing what we did was identification of center of excellence for each type of equipment and activities. Though we have in-house capability to engineer everything in India, but considering the time frame of the project, so we distributed the responsibilities across the divisions through the globe. Then identification of a focal point who can interact with the customer in all the divisions so that they can manage the show, being at the customer's site. Then we have a creation of interlocation task group. So this was a critical activity so that all the activities are completed in time and all the stakeholders are in one place so that decisions could be taken faster. Then we had weekly technical reviews, manufacturing and testing reviews per the project stage so that we could identify if there are any roadblocks and to solve them in timely manner. Then we had in-country support by key Indian team members in Brazil. So this was one of the key points which helped us to execute the project in time, because as you all know, that during the execution, there are so many roadblocks or the issues faced during manufacturing, testing activities. So it always helps to have somebody from the engineering team to be present there, right there in the site, to address all the concerns. The other key point was procurement capability. So we could leverage our global presence for procuring all of the key components across the globe to speed up the process. The other point what we could offer is 24/7 support to our Brazil team, so that any issue they face at any time, we could support at their time zones. So moving on, next we have some results and discussion on the challenges encountered and how did we address them. First one, during the initial stages of design, we had frequent requirement changes from the customer, which was really challenging, but we could address all of them, having frequent meetings, calls, task force creation. Then the very important thing is stringent timelines. So we had to work across time zones. So we could address this by working on shifts so that the schedule is not affected. Then language barrier, of course. None of us knew Portuguese, and half of the team there did not know the English, but still we could manage using some of the AI tools and having some key members placed in Brazil. Timely procurement. So some of the key components, for example, this large bore walls or flow line connectors based on the customer specification. So they required a lot of planning and coordination between our divisions. Then capacity requirement. As you see, the number of equipment which were delivered were quite high. So we had to ramp up quickly in all the functions, like be it engineering, manufacturing, or shipping. So we ramped up quickly all our capabilities to meet the deadlines of this project. So with respect to key takeaways in addressing this project, cross-culture or geography, team collaboration is really important. All of you agree in. We had to do that, otherwise there was no way. Sometimes it gets challenging to work with global teams, different cultures and different languages involved. Processes, really important to address any issues or avoid any issues rather. Then communication, clear and concise communication so that to avoid any misunderstanding and waste time or avoid iterations. Motivated team, very important. So we had lucky enough to have a motivated team to execute the project by taking special interest. Even though there is no instruction from the higher ups, the team used to take special interest to cover this responsibilities. Even if it is odd time, for them, they did that job. Then we have a turnkey project management capabilities in India right now. Though this, the case study project, we did it using all of our divisions capabilities across the globe. But right now we have capabilities right in India. So we can take up any of these projects for the customers in India or adjacent nations like Asia Pacific nations. Then we have ability to cost effectively manufacture and deliver key components. So as I said earlier, we have our own product line. It helps to satisfy all the customer requirements, not only in terms of overall equipment, but also on the product lines. So these are some of the experience what we had executing in this project. And we were quite successful in the project. Some of the equipment are being installed in this project. Overall, it's all team effort. And I would like to acknowledge my team and also our management. Our CEO is here, Mr. Sanjay Reddy. So his support was really good and encouraging. Thank you very much. Thanks.
Thank you, Mr. Suhas. Thanks for this wonderful talk. That brings us to the final talk of the session, which is coming from Halliburton. The speaker is Dr. Sarvesh Kumar, who will be speaking on seismic tiles, a novel approach for interpretation and prospect identification. A little bit about the speaker. Dr. Sarvesh Kumar is a senior geoscientist in Halliburton Limited. He's based out of Gurgaon. He has over 6 years experience in the energy sector and has led a wide variety of projects across the entire E&P life cycle. He has also worked on CCS screening projects for different Indian basins. Dr. Sarvesh holds a PhD from IIT ISM, Dhanbad in applied geophysics, is an author of more than 8 research papers in peer-reviewed journals, and also serves as a reviewer for several international journals. Dr. Sarvesh, the floor is yours.
Good afternoon, session co-chairs, my co-speakers and audience. My name is Sarvesh Kumar and I'm a senior geoscientist in Halliburton India JG team. First of all, I would like to thank IEW team for giving us this opportunity to present my paper here. And my paper is on seismic tiles. So this is a very novel approach for interpretation and prospect identification. This particular technology has been developed by Equinor in collaboration with Halliburton. This technology is now with the Halliburton, and We have the solution as a plug-in in distance-based geoscience for seismic and well interpretation, geological and geophysical interpretation. So in this session, I will talk about what is seismic tiles, then what is the methodology, then what are the key industry challenges, what are the solution we have, and how we can resolve that challenges using the seismic tiles. Then we will discuss about I will discuss about the case study which we have done for the seismic tiles, and last I will discuss about the conclusion. So starting with the seismic tiles here. So let's talk about what is seismic tiles. So seismic tiles is automatic extraction of millions of small reflectors segment from the large 3D seismic volume. So we can extract, we can basically convert or transform our seismic volume into small components, and then we can do our analysis over those components. So this particular illustration will give you idea about what is seismic tile. So if you look at this figure, you will see that the seismic surfaces are dipping in all direction, and the blue color tiles you are seeing is basically aligned with the dipping of seismic reflector here. So basically this particular seismic tiles are aligned with the dipping surfaces, and when these seismic tiles are connected combinedly, it forms the patches. We will discuss about what is patch. So when these seismic tiles are connected, it gives you idea about the surfaces, how my surface are varying, just like what we do in horizon interpretation. So basically here we have a process of automated extraction of seismic tiles, and then it gives the tile combines give you the seismic reflector. So basically each tiles here you will see aligns locally with the reflector, and individually they look like they are piece of seismic reflector, as you can see here, and these can be combined to form the patches as well. Now tiles can be stored in tabular form, as you can see in the right side. It can be stored in tabular format, and each row of this particular table shows the tiles. So each tiles will have an ID, and then it will have the attribute. So basically if you look at the columns, we have dip and dip in the inline direction, dip in the x-line direction, and these we can calculate number of attributes using these tiles. Any number of attributes can be automatically calculated from any data set, and these could be amplitude extracted from any other volumes or calculation between existing attributes. So this will be like we are just converting or transforming our large seismic volume into very small components, and then we are doing our analysis. Now to give you idea about an idea about the real world size of a seismic tile, in the order of 100 by 100 meters. So it could be large or small depending on the setting and our goals, basically what we are trying to find here. Now, for example, smaller tiles will work better where the geology is more complex. If the tiles we are choosing the bigger tiles, it means that we do not have very complex geology in that area. Now, coming to the industry challenge. What is the industry challenge actually, and how we are resolving with the seismic tiles? So the very first challenge is handling and interpreting the large seismic volume. We have we generally see we have large seismic volumes, which sometimes we do not able to handle very efficiently. So seismic tiles help you in handling the seismic volume in very efficient way. Now we have legacy seismic data, and we do not generally do the time-lapse study. So we can do time-lapse study here also. we do not do combined study of AVO and time-lapse study. So in seismic tiles, we have option of doing this together and getting the more accurate result in reservoir characterization. So what is the solution? So the solution is seismic tiles. So basically, it will transform your data into small tiles. Then we can do it will guide you in the structural interpretation. We can find the chi angle and chi liquid and chi fluid, basically the part of AVO attribute analysis, and then we can find the more prospect location, and then we can do the detailed study. Then tile comparison across vintages, like what we do in the time-lapse study. We can compare two vintages of seismic volume together, and then we can analyze how we can find the bypass zone or migration of hydrocarbon. So the idea is very simple. We have database. Now in that database, we already have the seismic volume. We will transform that seismic volume into the tiles, and then we will do the 4D attribute on AVO attribute analysis, and then we can go for the well planning. Now, what is the methodology? So methodology is very simple. We have the seismic volume, then we will convert it into the subcube. Subcube means we are just defining the inline X-line range. Like if you want to do extract tiles into 10 by 10 inline X-line, we can just define that parameters, and then it will extract the cube. The next task is applying the linear radon transform. So in the background of seismic tiles, basically it is applying the linear radon transform on the seismic cube, and then in the tau p domain, it basically picking the local extrema, local maxima of in the radon domain or the tau p domain. Now, once it is picked, the local extrema is picked, it will convert the tau p domain into again to the time domain, and it will look like a seismic tile. So this is the example. If you look at here, the dotted line is basically seismic tiles after applying this linear radon transform. So it is calculated automatically. If you look at here, it is very much aligned with the reflectors. Now, this case study I have carried out in the Hadron field. This is very well-known field and very mature field. And this particular field is heavily faulted in the Middle and Jurassic sandstone. So I will show you how seismic tiles help in identifying the fault zones and then reservoir zones. So coming to the result and discussion part, I have divided result and discussion part into two parts. One is how seismic tile is helping in my structural interpretation, and second part is how it is helping in advanced geophysical interpretation, which is AVO attribute analysis and 4D time-lapse study. So if you look at here, figure number 2, the first figure in the left side, each tiles are very much aligned with the seismic event. The regions where the seismic tiles are consistent, it is indicating the continuous horizon, and at some location you will see the discontinuity as well. So that discontinuity is because of the fault. So you can see how efficiently seismic tiles is discontinued at the fault location, and it will guide you in interpreting the structure. So if you look at it into the map view here in the right side, you will see each tiles are connected now and form the patches, and you can easily see the extension of time. Basically, it is just like extracting the horizon on the seismic amplitude. Now, the second part is the interpretation, the result and discussion of AVO analysis and 4D seismic. So I have applied this particular seismic tiles by doing the AVO attribute. In generally, AVO attribute analysis is done on, we calculate the gradient and intercept, then we can go for the chi liquid and chi fluid, and then identify the prospect zone. But here, you just need to put the chi angle, and it will give you the reservoir zone basically. If you look at the yellow encircled zone, that is basically the fault zone where we are getting the discontinuous tiles there. And the white encircled zone is basically the reservoir zone where we have two wells, well 1 and well 2, and that is why that is the reservoir zone. So that is, we are getting the high Chi fluid zone where we have the reservoir zone. If you look at there, this is very bright and the red, higher value of Chi fluid. In the lower part, I have carried out the time-lapse study. So basically, we have two vintages data, and when we compared it with the first seismic volume with the another seismic volume, we find that we are getting the low amplitude value, which suggests that hydrocarbon is moved from this location. That is why we are getting the low amplitude zone here. Coming to the conclusion, so what are the key takeaways from the seismic tiles? So basically, seismic tiles helps you in simplifying the complex seismic volume, because we are transforming our seismic volume into small tiles, and it becomes very easy for analysis and interpretation. Then before going to the detailed study, let's say we are doing any block evaluation or we are doing any due diligence, we do not have much time of doing AVO attribute analysis or time-lapse studies. So basically, it gives you prior knowledge of fluid and lithology effects before we go to the detailed AVO attribute analysis. So it will give you the prospect zones where you can focus, and then you can carry out your detailed study. Then we can do the time-lapse seismic study also if you want to identify the bypass zone or the migration of hydrocarbon in that zone. We can easily do the time-lapse study. So in overall, if I summarize the seismic tiles, so seismic tiles is very automatic process and scalable, which basically transform your seismic volume into actionable geological information, and then we can do the AVO attribute analysis and time-lapse study before going to the detailed study. So let's say if we are evaluating any block, then we should definitely apply seismic tiles, and then we can identify some of the zones for the detailed study. Thank you so much.
Thank you, Dr. Sarvesh. So thank you, everybody. Thanks to the audience for attending and also your participation and your